So here we go with question 2017, number 3, which of course falls in our non-calculator section. The function f is differentiable on the closed interval, f of negative 2 equals 7, and the graph of f prime is above. So 2 things to take note of. We have this great, again, it should be highlighted, initial condition about f. So anytime they're asking about f, we need to make sure we're using that. It's an initial condition about f. And they gave you the graph of f prime, so just keep that in mind. That's f prime, and you have a condition about f. So part A, the setup should be very straightforward. You want f of negative 6, and you have an initial condition, so you have to start with f of negative 2 plus the integral from negative 2 to negative 6. If I want f, I should be integrating f prime of x dx. Okay, so let's make sure that setup is perfect. The only little hiccup to catch is that the bounds are backwards. So f of negative 2, I'm going to go minus the integral from negative 6 to negative 2. Notice that's not in my first step. That would be a second step, dx. And now the math is very simple. They give you f of negative 2, so that would be my 7 minus whatever I get for this section. And an integral, again, is the area under the curve. So f prime is this graph. I am looking at its area from negative 6 to negative 2. So I'll just shade that in, which is very simple. It's just a triangle. So I'm going to go 1/2 base times height. My height is 2, and my base is 1, 2, 3, 4. So I'm going 1/2, 4 by 2. The half and the 2 cancel, so I would say that has an area of 4, which gives me a total value of 3. For the second part, they want f of 5. So f of 5 equals f of negative 2 plus the integral from negative 2 to 5 of f prime of x dx. Again, I'm just looking for the area under the curve. The bounds are in the correct order, so there's nothing fancy I have to do. I just need the area from negative 2 to 5. So negative 2 would be this semicircle till 5, which would be this triangle. So I need all of this area and this area combined. Now, the one thing I have to catch here is that this semicircle is sitting underneath the x-axis. So that's going to be a negative 1/2 pi r squared. And the triangle is my 1/2 base times height, and that is positive. So I'm going to start with my f of negative 2, which we said is 7, plus whatever I get for this section. I'm going to go back to my semicircle. That's negative 1/2. Pi, it looks like the radius would be a radius of 2. So I'm going to say that's a negative... Oops, I didn't square it. I'm sorry. So that would be 4. So that would be a negative 2 pi. And this triangle is a 1/2. Let's see, a base of 3 and a height of 2 would get me an area of 3. So notice how I just kept that second piece in brackets there just to say it's this plus this. So I would say that would be a total of 10 minus 2 pi. And again, I think that's a pretty straightforward question by now. Part B, on what intervals is f increasing? So again, I'm going to highlight that key calculus word. Increasing is telling me to take a derivative. Don't say I don't know who, just read the question again. It says of f. So I need to find when f prime is first equal to 0. Then I can say increasing is when f prime is greater than 0. So I first want to find those critical points to identify that to the grader and myself. And then when f prime is greater than 0. Now, notice this happens to be a graph of f prime, so you're literally just looking at this picture. It is greater than 0 when it is sitting above the x-axis. So I would say from negative 6 to negative 2, and from 2 to 5. Now you might be asking why I put brackets on the end of those two. It's just because I think that was a closed interval. That's where it went from, negative 6 to 5, so I just closed those in. All right, part C, find the absolute minimum value of f on the closed interval. So again, absolute, they're either going to say it or they're going to just give you the closed interval. That's when we make the t-chart. To find a min, there's your calculus term, you set the derivative equal to 0. And again, you don't have to guess, it's the derivative of, if you just read, f. So f prime equals 0 would get me all my critical points. And of course, I need the endpoint, so from negative 6 to 5, and I need every time that f prime equals 0. So I have to include negative 2 and positive 2. Now, who goes there? Again, it's not a guess. What are you finding in the question? We are finding the value of f. Then that's who goes there. Now, what's nice is you already evaluated some of these. If you look back to question A, you already found f of -6, so that work is done. You also already found f of 5, so that work is done. If I write my equation for f, let's see, f of -2 equals the initial condition, f of -2 plus the integral from -2 to -2 of f prime of x dx. You'll notice these bounds are the same. That gets me a 0 plus my condition of 7. So I think that gets me a nice 7. Then I would write my function for f of 2. So I start with that initial condition plus the integral from -2 to 2, f prime of x dx. So I need the area from -2 to 2. So -2 to 2 was the area of that semicircle, which we believe we said was -2 pi plus the initial 7. So I've got 7 minus 2 pi. So now we have to make sure we actually answer the question. And the question said, what is the minimum value? So I'm looking for the smallest. So let's see, I have 3 and 7, so 7's obviously not the smallest. 10 minus 2 pi, well, pi is 3.14 times 2, so 3 times 2 is 6, so that's 10 minus a little number bigger than 6. And this is 7 minus a number bigger than 6, so I'm going to say 7 minus 2 pi is the minimum value. And make sure you write your answer down. Lastly, for each f double prime of -5 and f double prime of 3, find the value or explain why it does not exist. So let's just start with f double prime of -5. So that would mean taking the slope of f prime, which is convenient because I have f prime. So I need to, let's see, 1, 2, 3, 4, 5. I need the slope right here, which is easy peasy because it's on a line. And if you know 2 points on a line, then you can easily calculate the slope. This other point would be -2, 0. So I can easily find f double prime of -5. I'm going to say that's 2 minus 0 all over -6 minus -2. So that's going to get me a 2 over -4. So I would say that has a f double prime value of -1/2. I now need f double prime of 3. Now your gut is going to give you the answer right away. And we're going to say clearly the slope there does not exist. Now why? Okay, you can't say because it comes to a corner. It's great to think that. You just can't say that. You got to use limit notation. So the limit as x approaches 3 from the left of f double prime of x does not equal the limit as x approaches 3 from the right of f double prime of x. Okay, I'm saying those slopes are not equivalent to each other. And again, that's because in my head it's coming to a nice cusp or corner.